Hello, ladies and gentlemen, and welcome back to distance learning. So we're now looking at exponential functions. So we're going to be talking about domains and ranges and graphs of these things, not just the laws, but what do these things look like as a graph. So this is section 6.4. Exponentials look somewhat similar to functions that you've seen before in that they involve exponents. However, there's a big difference. The variable is now in the power rather than in the base. So this is an idea of a exponential function. The base value, the number, has to be greater than 0 and it cannot equal 1. That's by definition. Okay, so when we created the whole group of exponential functions, we said that to be an exponential function, your base has to be greater than 0 and a cannot equal 1. Exponential functions have special feature. It's going to be called a horizontal asymptote. I don't think you've seen that before. You've seen vertical asymptotes. Nope, I don't think you've seen that before. So this is going to be a neat idea. This is a horizontal line that the curve gets closer and closer to, but never touches. It never reaches it. It's never going to cross it. So by definition, an asymptote is a straight line that a curve approaches but never touches or crosses it. So that's going to be a new concept for us today. And the word is asymptote. And we're going to be talking about horizontal asymptotes. So, recap, we're talking about exponential functions. An exponential function is anything that's going to look like this, where our variable is up in the exponent now. So here's an example. 2 to the x. Here's an example. 5 to the x. Here's an example. 8 to the x. Here's an example. 1 to the x. No! Ding, 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 ding! Not allowed. This a value equals 1. And we said that exponential functions have to have an a value that cannot be equal to 1. So this is not an exponential function. Okay, so let's take a look. Let's consider the function f of x equals 2 to the x. Let's sketch this. Well, we're going to sketch it using the very basic understanding that we know, and those are table of values. So we're going to choose some values of x here. Let's choose -3, -2, -1, 0. 1, 2, 3, 4. I just came up with those. They seemed like good values to use, and I threw them in. I could have used any values I wanted, but I chose those ones. I'm looking for a pen here. Okay, got one. Now, those are my x values. We choose what we want to put in there. Now, these x values are going to have a corresponding y value. So 2 to the -3. 2 to the -3, we have to remember, is equal to 1 over 2 to the 3. Because a negative exponent, we're going to put it in the bottom. 2 to the 3 is 1 over 8, or 1 divided by 8, 0.125. 2 to the -2. Because remember what we're doing here, our function is f of x equals 2 to the x. So if my x is -2, it's 2 to the -x, which is 1 over 2 squared, which is 1 over 4, which is 0.25. 2 to the -1 is 1 over 2, which is 0.5. 2 to the 0, anything to exponent 0 is 1. 2 to the 1 is 2. 2 to the 2, 4. 2 to the 3 is 8. 2 to the 4, 16. 2, 4, 6, 8. Who do you appreciate? Oh! All right, let's take a look at what we can do here. So, these are my x values. These are my y values. My x values are going 1, 2, 3, 4. -1, negative 2, negative 3, negative 4. Let's plot some of these. The easier one to plot is 0, 1. So it's going to be 0, 1 right there. This one's easy to plot. 1 and 2. 1, 2. 2 and 4. 2. 1, 2, 3, 4. 3 and 8. 3. 1, 2, 3, 4, 5, 6, 7, 8. 4 and 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Way up here somewhere. Let's go the other way. Negative 1.5, so halfway up. Negative 2, half of a half. A quarter is a half of a half, so half of that distance. Negative 3, a half of a quarter. So it's going to be half of what that is. And then the next will be half of what that is. And the next will be half of what that is. And it'll always be half the remaining distance left over. And it will get closer and closer to this horizontal line, but it will never, ever, ever touch. Because in mathematics, there's always a space. If you move half the distance and half the distance and half the distance, then there's always half remaining. What that creates is what we call a horizontal asymptote. That's this line right here. That is the line that the curve is getting closer and closer to, but never touching. And its equation is y equals 0. It's also called the horizontal axis. And this is the curve. That's the exponential curve in each of these points. So 0, 1, 1, 2, 3, 8. I think I've missed something here. 0, oh yeah, that's 2, 4. Blah. 2, 4, 3, 8. 4, 16. Over here, it's negative 1, 1 half. It's negative 2, 1 over 4. This will be negative 3, 1 over 8, half of a quarter. That's your exponential function of y equals 2 to the x. What are the domain and range of this function? The domain are all the possible x values that can go in. So the domain is x is an element of the real numbers. What's the range? Well, the range are all the possible y values. So it's going to be y is greater than. Can it equal 0? Can it ever cross or touch this line? No. So it's got to be greater than 0. And y is an element of the real numbers. What are the x and y intercepts? Well, it doesn't cross the x-axis, so there are no x-intercepts. Never touches or crosses the x-axis. What about the y-intercept? It's right there. Y-intercept is 0, 1. Find the intervals of increase or decrease. Now remember, that's going left to right. So from left to right, we are only increasing. So y is increasing from negative infinity to positive infinity for x. So as x gets larger and larger and larger positively, so does y. One way of saying that is, as x increases, y increases. Another way to say that, sometimes people say, as x approaches positive infinity, y approaches positive infinity. All of these say the same thing. Find any asymptotes. There's a horizontal asymptote. At y equals 0. That's its equation. We also call it the x-axis. All right, so that's example 1. I'll stop here and we'll do example 2.